Hey there everyone, this is Dan from the Strength Coach Tutor. Today we're going to go over calculating equipment space needs. And this is all from chapter 23 from the textbook in regards to facility design. And so we're going to use these equations to figure out how much space does this piece of equipment need when we're, again, designing our new facility or modifying an existing facility. So let's go ahead and get started. So this table that I have listed out here is table 23.2 from the textbook. And you can see we have three columns. We have the area, which is basically the type of exercise that we're going to do, like in terms of what category we're going to fill that in. The next is going to be examples of exercises that are going to be performed in those areas. And then on the right column is going to be the formula in terms of how to calculate how much space we actually need. So on this slide, we'll go through what all these essentially mean, these examples and so forth. And then on the following slide, we'll go through specific examples of what this would look like and how to, where these numbers fit into these equations and so forth. So the first category we have is our prone/supine exercises. If you're unaware, prone simply means an exercise that you're doing with your chest and stomach on a bench or on the ground, whatever it may be. And supine is simply the opposite of that, where anytime that you're doing exercise where you're on your back, like a bench press, anything of that nature. And so examples of these exercises would be like a bench press or a lying triceps extension, right? You could also do, if you're doing any type of like seal row or like bench supported dumbbell rowing, those would be examples of a prone exercise. And so what they're telling us here in terms of how to figure out how much space we need to know the weight bench length, so the bench that we're using, what's its length, and typically that's going to range anywhere from 6 to 8 feet. And we're going to add that number to the safety space cushion, which is 3 feet. So we would add those two numbers together. And then what we'd then do next is take the user space width, which would be about 7 feet, add it to the safety space cushion, which then 7 plus 3 would be 10. And then we take those two numbers that we just got from adding, remember, because they're in parentheses, we do what's in parentheses first, and then we would multiply those two numbers together in order to get the square footage. The next one we're going to look at here are standing exercises. So this would be your biceps curl, upright row, maybe you're doing like a standing dumbbell shoulder press, whatever it may be. So first, what we're going to do here, we're going to take the bar length, which would be anywhere from 4 to 7 feet, depending on the type of bar that you're using. In the textbook example, they do, use an example of a curl bar, and a curl bar is 4 feet long, but typically, like your Olympic bars, for example, are going to be 7 feet long. So again, the bar length is going to vary. They may give you that in the question, in the description, or they may not. But it's good to know that the curl bar length is 4 feet, and that the Olympic bar length is 7 feet. So again, going back to the standing exercise formula, you're going to take the bar length and add it for a double wide safety space cushion of 6 feet, right? Because you need 3 feet on each side of you. So 3 plus 3, of course, would equal 6. And so that's where they're getting that 6 feet from. So you're adding the double wide safety space to the bar length. Remember, we're doing that separately in its own set of parentheses. And once we get that number, we're going to multiply it by the user space for standing exercise width, which would then be 4 feet. So basically 2 feet on each side as well. That's what we're looking at there in terms of creating enough safety space for us to perform this exercise. And you just multiply those two numbers in order to get your square footage. Next, we have standing exercises in a rack, so such as your barbell back squat, your barbell shoulder pressing, barbell front squat, even deadlift, if you were deadlifting in a rack, things of that nature. We're going to end up using a barbell of 7 feet. And so what we're going to do there is you're going to use your bar length plus a double wide safety space cushion of 6 feet. Again, add those first because those are in parentheses. Then multiply it by the suggested user space for a standing exercise in a rack, which is anywhere from 8 to 10 feet. All right. And then lastly here, we're going to talk about Olympic lifting, which of course is going to be your power cleans, your snatches, your hang cleans, your hang snatches, whatever it may be. You're going to take the lifting platform height of 8 feet plus perimeter walkway safety space cushion of 4 feet. You're going to add those two together first, times the lifting platform width of 8 feet, plus the perimeter walking safety cushion of 4 feet. So really, the numbers in this equation don't change at all. It's they really use the same safety space no matter what exercise you're doing or what type of equipment, because you're still going to only use an Olympic bar, and the platforms are all going to pretty much be the same size. So it's really the same number here. And we'll look at that example when we get to this next slide here. So again, on this next slide, though, we're going to look at specific examples of each of these situations, if you will. So our first example is going to be the prone/supine exercises. And in this example, we're going to use a bench length of 6 feet. So we're going to first do the 6 feet plus the 3 feet of safety space times 7 feet plus 3 feet. So what that really gives us is 9 times 10, right? Because we got 6 plus 3, that's going to equal 9. And then, 9 plus 3 is going to equal 9. And then 7 plus 3 is, of course, going to equal 10, right? And so we would then have to do 9 times 10, and that's going to give us 90 square feet. For standing exercises, we're going to use the example of a bicep curl exercise with a curling bar, which is going to be 4 feet. Now, in this example here, we're going to do 4 feet plus 6 feet. And that's going to give us 10. So next we would have to do 10 times 4, and that would give us 40 square feet.
Now let's look at standing exercises in a rack. In this example, again, we're going to use the Olympic bar length of 7 feet. And so again, we're going to take that 7 feet plus 6 feet. Again, 6 feet meaning 3 feet on each side for safety space. So we're going to add those two numbers together. 7 plus 6 would then be 13. And then we have to multiply that by 10. And 13 times 10 would be 130 square feet. And then lastly here, when we look at Olympic lifting, whether it's going to be your power clean or snatch, again, we're going to do a really basic formula here. Honestly, this is the easiest one. It's very straightforward. They only give you the numbers 8 and 4 to work with. And so any question that you have to get in terms of calculating space needs for Olympic lifting, their recommendations are the same numbers every single time. The platform size is pretty standardized for Olympic lifting, so that's to our advantage when we're solving these types of questions. So if you can understand that, it's 8 feet in terms of height for the platform, and then it's also 8 feet here in terms of the width for the platform, that's where those numbers are coming from. And then 4 feet is really safety space on each side, covering each of the 4 sides of that rectangle, of that, or I should say square, of that platform, if you will. So really it's just 8 plus 4, which is 12, and 8 plus 4, which is 12. You end up having to do 12 times 12, and that's 144 square feet. All right, guys. So that's it for today's video. This is how to calculate space needs for equipment. This was table 23.2. There is another table, 23.1, I believe, off the top of my head, which is calculating equipment space needs for cardiovascular equipment, but that is very easy and straightforward. It just gives you the recommendations in terms of like how much square footage do you need for a treadmill, how much do you need for a bike, for an elliptical, etc. So that is much simpler. It's just honestly just memorizing those numbers. But this, you have to understand where these numbers are coming from, why they're being plugged in, and and why do we need this much space to perform certain exercises. And as you can see, as we go down to Olympic lifting here, Olympic lifting requires the most space because it is inherently the most dangerous, and we want to provide them as much space as possible to perform that exercise safely for the lifter and also for everyone else in the weight room. Again, guys, thanks for watching today's video. If you need any additional studying help or studying materials or even practice questions or exams, please head to thestrengthcoachtutor.com and check out our online classroom. And if you need more one-on-one assistance, I also offer individualized tutoring as well. Once again, guys, thank you guys.